Okay, hello again. So, today we are going to discover a very special formula in high school math. Very useful. It's really, I think, the true. This is where we start to see where the geometry comes in instead of just the algebra. So, let's just examine part A of our problem, and then part B is asking us for a generalization of what we're going to do in part A. So part A says find the length of the segment with endpoints -4, -3, and 6, 1. So, all right, let's graph those. We got -4, 1, 2, 3, 4, then down 1, 2, 3. All right, there's our point there, and I can call this, I don't know, point A. Yeah, sure. Okay, and then the second point is 6, 1. So 1, 2, 3, 4, 5, 6, up 1. And we could call that point B. And the distance that I want to find is the distance between those 2 points. So, basically want to draw a line from one point to the other. So now I got this line segment with endpoints A and B. Very cool. So how do I find this distance? Can I just count it out? Well, no, I mean, not really. Just know you can't really count diagonally. It's not good. But what we can count is like horizontal distances and vertical distances. Straight lines basically. So why don't I just think? Well, in terms of x, my distance from A to B is from like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have to travel a distance of 10 in the x direction to get from A to get to the A's x coordinate to B's x coordinate. Okay, very cool. So now I can count the distance in the y direction. Well, that's going from where we ended up. I have to go up 1, 2, 3, 4. Okay. Well, I know that vertical distance along the x-axis, that is a length of 4. Very cool. And what's really cool is that, if I can call this point C, well, this is going to be a right angle. A right angle. And right angles mean right triangles, and right triangles mean Pythagorean theorem. So, if I can use Pythagorean theorem and treat the distance from A to B as my hypotenuse, then I can find the length of AB. Hence, I can find that the distance between those two endpoints. So, we got I'll cut this off like this. Okay. I have AB squared is equal to AC squared, which is 10, so 10 squared, plus BC squared, which is just 4 squared. And if you don't remember Pythagorean theorem, just go back, watch some of my videos on it. It's not that bad. But whenever you see a right triangle, you should pretty much always think Pythagorean theorem or SOHCAHTOA or one of those things. But in this case, we're just going to use Pythagorean theorem. So, okay, 10 squared is 100, and 4 squared is 16, so that's 116. So AB squared is 116, which means that AB is equal to the square root of 116. And again, if you're not understanding why I just got the square root, just go back and watch Pythagorean theorem videos. It covers all that. Basically, if AB squared is 116, I don't care about AB squared. I want AB. I want that distance. So you would cancel out the AB squared by taking the square root. And if I'm taking the square root of AB squared, I have to take the square root of 116. All right. So, can I simplify 116, the square root of 116. Well, my trick to this is always like, how can I say it? Divide, your 116 by perfect squares, because if you divide it by like a perfect square or something, then you know that you can simplify the radicals. So, I can start, okay, I can take this 116 and, divide it by, well, the first perfect square is 4. So 116 divided by 4, does that give me a whole number factor? Yes, it does. So 116 is the same thing as 4 times, was it 29? Now, 29, you're not breaking down anytime soon. It's a prime number, but that square root of 4, I can most certainly break down. AB is equal to, square root of 4 is just 2, and then we have the leftover square root of 29. So that is the length of AB. 2 square root 29. Very cool. Okay, so that answers part A. The length of the segment with the endpoints -4, -3, and 6, 1 is 2 times the square root of 29. Very cool. And we use Pythagorean theorem to do that. But part B is asking us for a formula using these arbitrary points x1, y1, and x2, y2. Well, pretty much whenever we're developing a formula, we just use the same idea we did to get the answer without the formula. So like A, right? Coordinate A is basically going to be like my x1, y1, comma, y1. And we were given the other coordinate B, which I can say that's my x2, y2. Okay, so let's really think about where we can take this. So I'm just gonna go down a little bit. Okay. So pretend like, hold on. Pretend like, sorry, you didn't see any of this. God, keep messing it up. All right. Pretend you didn't see any of those numbers there because I want to explain them. So like I said, we're going to start. We got A is our x1, y1. B is our x2, y2. And we're trying to find the distance from A to B. And in the original problem, we did that by counting the horizontal distance and the vertical distance and meeting at the point C, which we can see right there. And it makes a right triangle. So through some logic, let's look at, like, in our original example, this coordinate C, this C coordinate, that ordered pair that it's using is the x value is 6. If we look at the origin, it goes 1, 2, 3, 4, 5, 6 on our grid. So C has that x coordinate of 6, and it has that y coordinate of going down 1, 2, 3, -3. And this kind of makes sense. It's using this point C is using the y coordinate of point A and the x coordinate of point B. So we can apply this same logic, like here. Like, another way to look at this is, okay, 6 is our x2. That's the value of the B's x value. And our coordinate C uses the value for y1, which was from A. And we can apply the same logic to point C in this triangle, where basically just creating the same scenario. I don't want to draw a grid because it would be too much. So hopefully you can just kind of like understand how this figure would apply to the coordinate plane. You can just throw those points anywhere, but we just want to generalize them. So because if you use specific numbers, you're not going to get a formula. We want to assume that I don't know what any of these numbers are, but we can deduce that that point C must have the same x value as B and the same y value as A. Because, I mean, if you look at C, it's vertically in the same position as A and horizontally in the same position as B. Very cool. So that's not enough, though. If I'm trying to use Pythagorean theorem, which I am, since we have a rectangle, I need to know the distances of AC and BC. Well, the distance from A to C, well, I mean, our y values are the same, right? So there's no distance change in the y values. The only distance change is in those x values, x1 and x. We go from x1 to x2. And since x2 is more towards the right, that's going to be the larger of those two values. So this distance from A to C would be x2 minus x1. That's that total distance. And, you know, you can tell, like, look at the coordinates in our original problem. A was 4, -4, -3. C is 6, -3. The y values didn't change, but that -4 transformed to +6, which is exactly what would happen if we did 6 minus -4, you know, because the distance is 10 and 10 is equal to 6 minus -4. So it's that distance of 10 is just the difference between the two x coordinates. So that same rule can be applied here. And similarly, the distance between B and C is just the difference in the y coordinates. The x coordinates are the same, they're both x2, but the change from B to C comes from the difference of the y coordinates. So the length of BC is going to be y2 minus y1. Alright, hopefully that was pretty clear. I know it's a lot of wordy mumbo jumbo, but hopefully, you know, it makes sense. So, alright, now we got this beautiful right triangle we can work with. We set up Pythagorean theorem. AB is our hypotenuse, so AB squared is equal to AC squared plus BC squared. Well, AC squared we know is x2 minus x1. So it's x2 minus x1 squared. Plus BC squared, which we know is y2 minus y1 squared. Alright, so again, we got AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. And, well, again, I'm trying to solve for AB, not AB squared. So the way to remedy this would just be to take the square root on both sides. So take the square root on the left, which what you do to the left, you're also going to do to the right. Square root all that. And this leaves us with AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that is our formula. The distance of AB is the square root of x2 minus x1 squared plus y2 minus y1 squared. And it's really all it is Pythagorean theorem. That's all it is. It's just Pythagorean theorem. But by writing it out like this, it gives us a very quick way to calculate distances if we just know the points. So this formula we just discovered is called the distance formula because it calculates distance. So for any 2 points in our plane, x1, y1, and x2, y2, we can calculate the distance between the two by taking the square root of x2 minus x1 squared plus y2 minus y1 squared. Then again, this is called the distance formula. It's the same thing as the Pythagorean theorem. So if you know the Pythagorean theorem, it's really not hard to retrace the steps to get this formula. So honestly, I wouldn't even recommend memorizing it, because if you understand Pythagorean theorem, this should come very intuitively. And yeah, like that's pretty much what I got. We're gonna use it in the next problem to help us out, but now you know a way to just calculate the distance between any 2 points on your graph, and I'll show you a direct consequence of using this formula in the next video. So stay tuned for that one.